Now let's look at basic properties of natural logarithms. A natural logarithm is a logarithm in which the base is e. So if you had a base of e, and it doesn't matter what this is, the way you could rewrite this is they'll say ln, which means the base is e of x. So you wouldn't write the e at all. So again, a common logarithm is a log with a base of 10. A natural logarithm is a base of e. All right, so here it says ln e of 4.6 here. Some things you need to know is, one, the base is down here. The base is e. Now this is saying this is my number, and it should be equal to some power over here. So if I rearrange this, I would say that the base, e to the power of x, equals my number, which is e to the 4.6. I find out that x equals 4.6. It's from this theorem. We get a lot of other properties with logarithms, and that's this. If you ever have an exponent, you can always move it to the front, because here you see that our answer is 4.6. If I were to come over here and do this again, what you'll see is when you have ln e to the 4.6, anytime with a log, you can move the power out in front. So I would have 4.6 times ln of e. If you go through and solve this one, you'd say, oh, my base is e, this is equal to x, so e to the x equals e to the first, so x would equal 1. Well, then you would multiply. 4.6 times 1 would equal 4.6. And you see you get the same answer. It's just two different ways of doing it. I stick with the way I've been doing it every time. It's just, to me, it's easier because we're consistent. Now here, again, I have a base of e. I need to set this equal to x. E to what power? Equals negative 1.2. Answer is no solution. Again, you cannot have a negative x value for your answer. It's just not in the domain. So we're not going to have any solution here. We'll check our graph real quick just to double check. So I'll go over to the graph here, and instead of looking at the common logarithm, this time I'm going to do the natural log, which is right here, ln, and the value was negative 1.2, I believe. Let me check real quick. Yep, negative 1.2. Oh, no, I want to graph it with an x. And you'll see at negative 1.2 for the x, the graph doesn't exist, so it doesn't work there. And if you weren't sure, you could come over here, and if we, let's come over here, I'm sorry. Let me delete these out of there. If I wanted to try to find it, I can go ln of negative 1.2, and you'll see this is no solution. All right, so it's not a real solution there. So let me put these over here, and we'll move on. So you can see the graph, it does not exist at negative 2. Oops. Negative 1.2, I'm sorry. Just doesn't exist. All right, and here, now this is in exponential form. So we have base to the power equals some number. I can convert it and say log, my base is e, to some number, which is the x, equals the power, which is ln 4. Well, this on the left is equal to ln x equals ln 4. So guess what? X equals 4. All right, and now evaluate this. Again, my base here is e, and I don't know, this is my number, but I don't know my power. I could convert it to exponential. E to the power of x equals 7. Now we don't know what that is, so the easiest way is just to type in ln of 7 in the calculator. So I'm going to come over here, and I'll type in ln of 7, and that would be my answer here. So now I'll take this back over, and we know that x would equal 1.94, and I'm going to round to the nearest thousandth, so it would be 946, and that's our value. Okay, you can try this one.